We saw that the productive forces resulting from cooperation and division of labor cost capital nothing. They are natural forces of social labor. So also physical forces like steam, water, and when appropriated to productive processes cost nothing. But just as a man requires lungs to breathe with, so he requires something that is work of man's hand in order to consume physical forces productively. A water wheel is necessary to exploit the force of water, and a steam engine to exploit the elasticity of steam. Once discovered, the law of the deviation of the magnetic needle in the field of an electric current, or the law of the magnetization of iron, around which an electric current circulates, cost never a penny. But the exploitation of these laws for the purposes of telegraphy, and necessitates a costly and extensive apparatus. The tool, as we have seen, is not exterminated by the machine. From being a dwarf implement of the human organism, it expands and multiplies into the implement of a mechanism created by man. Capital now sets the labor to work, not with a manual tool, but with a machine which itself handles the tool. Although, therefore, it is clear at the first glance that, by incorporating both stupendous physical forces and the natural sciences with the process of production, modern industry raises the productiveness of labor to an extraordinary degree, it is by no means equally clear that this increased productive force is not, on the other hand, purchased by an increased expenditure of labor. Machinery, like every other component of constant capital, creates no new value, but yields up its own value to the product that it serves to beget. In so far as the machine has value, and in consequence, parts with value to the product, it forms an element in the value of that product. Instead of being cheapened, the product is made dearer in proportion to the value of the machine. And it is clear as noonday that machines and systems of machinery, the characteristic instruments of labor of modern industry, are incomparably more loaded with value than the implements used in handicrafts and manufacture. In the first place, it must be observed that the machinery, while always entering as a whole into the labor process, enters into the value-begetting process only by bits. It never adds more value than it loses, on an average by wear and tear. Hence there is a great difference between the value of a machine and the value transferred in a given time by that machine to the product. The longer the life of the machine in the labor process, the greater is that difference. It is true, no doubt, as we have already seen, that every instrument of labor enters as a whole into the labor process, and only piecemeal, proportionally to its average daily loss by wear and tear, into the value-begetting process. But this difference between the instrument as a whole and its daily wear and tear is much greater in a machine than in a tool, because the machine, being made from more durable material, has a longer life, because its employment, being regulated by strictly scientific laws, allows of greater economy in the wear and tear of its parts, and in the materials it consumes, and lastly, because its field of production is incomparably larger than that of a tool. After making allowance, both in the case of the machine and of the tool, for their average daily cost, that is for the value they transmit to the product by their average daily wear and tear, and for their consumption of auxiliary substance, such as oil, coal, and so on, they each do their work gratuitously, just like the forces furnished by nature without the help of man. The greater the productive power of the machinery compared with that of the tool, the greater is the extent of its gratuitous service compared with that of the tool. In modern industry, man succeeded for the first time in making the product of his past labor work on a large scale gratuitously, like the forces of nature. In treating of cooperation and manufacture, it was shown that certain general factors of production, such as buildings, are, in comparison with the scattered means of production of the isolated workman, economized by being consumed in common, and that they therefore make the product cheaper. In a system of machinery, not only is the framework of the machine consumed in common by its numerous operating implements, but the prime mover, together with a part of the transmitting mechanism, is consumed in common by the numerous operative machines. Given the difference between the value of the machinery and the value transferred by it in a day to the product, the extent to which this latter value makes the product dearer depends in the first instance upon the size of the product, so to say, upon its area. Mr. Baines of Blackburn, in a lecture published in, estimates that each real mechanical horsepower will drive self-acting mule spindles, with preparation or throstle spindles or looms for inch cloth with the appliances for warping, sizing, and, in the first case, it is the day's produce of mule spindles, in the second of throstle spindles, in the third of power looms, over which the daily cost of 1 horsepower and the wear and tear of the machinery set in motion by that power are spread. So that only a very minute value is transferred by such wear and tear to a pound of yarn or a yard of cloth. The same is the case with the steam hammer mentioned above. Since its daily wear and tear, its coal consumption, and are spread over the stupendous masses of iron hammered by it in a day, only a small value is added to 100 weight of iron, but that value would be very great if the Cyclopean instrument were employed in driving in nails. Given a machine's capacity for work, that is, the number of its operating tools, or, where it is a question of force, their mass, the amount of its product will depend on the velocity of its working parts, on the speed, for instance, of the spindles, or on the number of blows given by the hammer in a minute. Many of these colossal hammers strike 70 times in a minute, and Ryder's patent machine for forging spindles with small hammers gives as many as strokes per minute. Given the rate at which machinery transfers its value to the product, the amount of value so transferred depends on the total value of the machinery. The less labor it contains, the less value it imparts to the product. The less value it gives up, so much the more productive it is, and so much the more its service is approximate to those of natural forces. But the production of machinery by machinery lessens its value relatively to its extension and efficacy. An analysis and comparison of the prices of commodities produced by handicrafts or manufacturers, and of the prices of the same commodities produced by machinery, shows generally that, in the product of machinery, the value due to the instruments of labor increases relatively, but decreases absolutely. In other words, its absolute amount decreases, but its amount, relatively to the total value of the product, of a pound of yarn, for instance, increases. As already stated, a steam plow does as much work in 1 hour at a cost of 3 pence, as men at a cost of shilling. I return to this example in order to clear up an erroneous notion. The shillings are by no means the expression in money of all the labor expended in 1 hour by the men. If the ratio of surplus labor to necessary labor were %, these men would produce in 1 hour a value of shillings, although their wages, shillings, represent only their labor for half an hour. Suppose, then, a machine cost as much as the wages for a year of the men it displaces. Say pound. This pound is by no means the expression in money of the labor added to the object produced by these men before the introduction of the machine, but only of that portion of their year's labor which was expended for themselves and represented by their wages. On the other hand, the pound, the money value of the machine, expresses all the labor expended on its production, no matter in what proportion this labor constitutes wages for the workman and surplus value for the capitalist. Therefore, though a machine costs as much as the labor power displaced by it costs, yet the labor materialized in it is even then much less than the living labor it replaces.